very good evening and a warm welcome to today's hands-on bootcamp where you will get to build a fully working application in just under 30 minutes. I am 𝗖𝗲𝗵𝗂𝘂𝘶𝗵𝗂 and I'm the Director for Community and Partnerships with OpenWeaver. OpenWeaver is a SaaS technology company supporting over 1 million developers worldwide build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Very simply put, we'd like to improve the way applications are built. We do this by investing in a unique combination of both public domain knowledge and artificial intelligence. So coming to today's bootcamp, this is an integral part of our OpenWeaver community initiatives. The OpenWeaver community is a body of like-minded technology enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex use cases can be developed by reusing open source. Over the last few weeks, we have run several such open source development bootcamps on a variety of topics, such as building your own AR-powered e-commerce site, building your own ChatGPT, building a breast cancer prediction engine, building an object detection engine, basics of Python programming, and many more to come. Through these bootcamps, you will realize that technology does not have to be complex and definitely does not have to be developed in silos. You will see how you can take a solution that is pre-built, in fact pre-built by many people in the world, and then you can build on top of it and share it back such that your solution can now be accessed by many other people in the world who can then further build on top of your ideas, thereby accelerating this virtuous cycle of innovation and also helping you scale your ideas and bring it to life much faster. So with that brief introduction, I will now welcome our mentor for today's session, 𝗷𝗲𝗀𝗂𝗂𝘂𝘶, who is a senior developer advocate with OpenWeaver.
Hello everyone, welcome to this session where we are going to discuss how you can generate your own music using Meta's MusicGen. So I guess this is going to be a very exciting application that we are going to develop today. And to get started, let's get into the agenda for the session. So for today's agenda, we will first talk about Meta's MusicGen. That is the model that we'll be using to develop or let's say generate our own commercial music can also be generated using this tool. So that is going to be the most powerful thing that we are going to be developing today. We'll also do a simple snippet exercise that will help you do many such exercises on kandi platform, and then we will get into the solution source as to how this solution has been developed today. So before we go ahead and discuss the concepts of this session, I guess we will first check out what is our solution and exactly what are you going to get from today's session. So to showcase you that, this is our model, and for now I had put up the input text. There are two ways in which we can generate music from it. One is either you give it a text or either you use both text as well as a melody. So this is another method where we would combine a melody, music, and as well as text to generate a fresh music or a new music of our own. So this takes a lot of time. I have set the duration to 3 seconds for now, and then I had submitted this, and based on that I would just want you to also get a hint of the generated music. I'll have to reshare my screen for that, but so that my audio with the music is also audible to you, all of you. So I've just put on cheerful country music with acoustic guitars. I just want to check for the duration that it has been generated. So that's what our AI has just tried to generate this one. However, I would also try to give you a very interesting prompt. We'll just put the prompt and then let the model run, since I'm running it on a CPU. So it will take its own sweet time, okay? So we'll let it run. I'll submit this for now, and then we'll get back after we set up this kit onto our systems to check the solution. It will take somewhere nearly around 300 seconds. So we'll let it generate, okay? And this requires minimum 16 GB of memory is what being said. We see that nearly 11 GBs is occupied by this model itself. So we'll let it run. And in the meanwhile, I'll get into the discussion as to how you can set it up. And as this will get set up, we will talk about the concepts, what and how Meta was able to give a very competitive model as compared to Google's MusicGen. So to set the kit up, you have to get onto the community platform where you are currently viewing this session. So you are viewing this live bootcamp session on this page, and under the resources section, you would see that there is an option for the kandi one-click kit. A couple of you have already started clicking and checking it already. So if you see that, if you scroll down, there is an option to receive an open source enthusiast badge. For that, you'll have to follow the steps that I am telling you just now, and just try and maybe change the pre-trained model or make some changes and share, sign up on the community platform, use this reply feature, share the screenshot, and you will receive an open source enthusiast badge that you can flash on any social media platforms. Also, you can interact with these polling questions that are available here specifically for you to check out and see what is your current knowledge on models or AI generated music. Okay. So let's get into setup of the kit. So for that, I'll click on the kandi one click kit. So this is a kit where you don't have to, set up everything from the scratch. We created a solution where with a few clicks, you are able to get it completely set up onto your systems. So for that, I can check out my deployment information that has been provided. Also read through the text that will help you guide as to what this particular kit is about. And then you can go ahead and click on the one-click installer. So this will download a zip file. You just say show in folder. So we can extract the contents of this folder. Double click the extracted folder. You will see a batch file within it. Double click this batch file. Say more info, run anyway. This will start setting this kit up onto your systems. So let this setup happen. In the meanwhile, we will discuss the concepts for today's session. You can minimize the screen and listen to the concepts for the session. Let the setup happen. All right. So we want to talk about music generation using the MusicGen, which is our Meta's latest model that has been very recently released. And this is something that we have seen beyond, let's say, generation of images from text. And we've been seeing a lot of this happening these days. This is a model that is better than the music LM that was introduced earlier by Google, and it promises to generate exceptional quality music using a single language model architecture. And it does this by using an efficient token interleaving technique. So we'll talk about that part as well. So exactly what is there in the architecture, and despite generating music for a couple of seconds, since I'm showing it onto your CPU, in case you don't have, if you have a GPU, that's great. You could actually run it really fast onto your systems, but we try to keep these kits good enough to be run on most of our systems. So this has an potential to be conditioned by both text or melody. So if I'm using a text to say, okay, generate even an Indian classical music, that could also be done. And similarly, you could say, alongside with melody, you could say convert it into a particular sort of a melody based on the melody that you have given. So I will showcase you all of that. And first of all, talk about the benefits of this model. So it's easy to use. It's a very it has an interestingly user-friendly interface. It is both accessible for amateurs and professionals. So you don't have to have the complete know-how of the tech. but you could also use this kit to generate music of your own. Only requirement is that you have the required bandwidth, the required computational resources. So the melody that is being generated is unique. So this is what makes it really interesting. So the algorithm is sophisticated enough that it is generating every time a fresh or a new melody for the same prompt. So this is something that you can all use to generate music of your own, and it has been seamlessly being integrated. So it is compatible with any software that you use for generation and as well as editing of your music. Let's say Ableton Live, Logic Pro X, and FL Studio. So that is what makes this really interesting. We want to talk about how this music gen actually works. So first steps, we want to collect, where there was a lot of data which was used to create the neural network that was able to analyze and understand and collect massive amounts of, I mean, first step was collection of data, which was music based data. And to be more specific, music data is really complex. It's not just any simple speech that you have to generate or answer you have to generate as text. Basically, when we are talking about music, we have to get to the frequency, harmony, the essence of what is being generated. So the data collection in itself was complex, and that was analyzed, and then it was cleaned up in a way. Then the pattern recognition happened as a step two, where the patterns within the data was recognized to create new melodic sequences. So that pattern recognition became as a step two, so that music generation could actually give us the exact required expected music. Then third was algorithmic composition. So the patterns that were generated for the new melodic sequence, that basically were used, and from those patterns the unique melodic and harmonic progressions were produced using the mathematical algorithms that we are going to talk about today. So the entire architecture is based on the encodec, which was earlier present, and there are additions onto the convolutional neural network that has helped us generate a more interesting form of music. So we say that it is helping us create melodies. Okay. So how do I do it? I can choose a style that I would like to, the kind of music that I would like to generate. So first of all, the genre, you can set the parameters if you would like. So we are saying your duration, like let's say for now, we have just given the duration for which you should generate your music. But from the code, you could also set up various other parameters that can help you with the diversity of the music that is being generated. And accordingly, once you have generated, you can preview and download it and edit it accordingly. As you can also generate an MIDI file for further editing. That's the most interesting part about the model that we have used today for generating this music. So how do you customize your music gen's melody? Uh, First thing is it offers advanced options. You can adjust the rhythm, harmony of the melodies. So that helps you create intricate musical arrangements. So if currently I just gave some country music, right? I could keep it simple. So here also it is more about the kind of prompts that we are using to generate the music accordingly. So it will be something which will be more interesting for people like who are actually into this music generation a lot. So I think I just had loaded that very interesting the melody. I had actually loaded it and tried to showcase you. So I would quickly move you through the generated answer here. Okay, it was the input text was a classic reggae track with an electronic guitar solo. I just want to showcase what it had been it has been able to generate. Again, I'll have to share it with the audio, so just give me one more minute. I'll share the screen audio with you guys. So I guess this is far more interesting with the previous one. So depending on the kind of input text that we give. Accordingly, it will generate the expected music. If you would like me to test with an input text, you could put it in the chat and I can pick it up from there and input it here, and then we could run the model, because it takes nearly 4 5 minutes of our time. So I would need you to put it in the chat as of now, and we can paste it and let this music generation app generate the required music and check. So this is completely unique. Okay, this is not something that we are picking from somewhere. You could actually use it, edit it, and increase the duration. But then GPU or exceptionally good resources will be helpful, so that it doesn't let your system be consumed of all the resources. All right. So getting back to our discussion about our PPT, yeah. So we can actually, generate advanced rhythms and harmony. We just saw that I had given a classic reggae track with an electronic guitar, which sounded really well as compared to another prompt like, the cheerful country music with acoustic guitars. So it completely depends on the prompt that you give, and accordingly the generation happens. Also, you could randomize the function to generate unexpected yet creative melodies and chord progressions. So the more randomization is required, you have to tap into parameters such as top T. There is, you know, there are other parameters such as you set the sampling and various other parameters that you can set. We will talk about those parameters as we will discuss going further as to how create a music specific to your needs. And then the capability to import your own MIDI files that will help you, generate, edit, create, and enhance the quality of music that is being generated. So, what are the types of pre-trained models that are available? So, today we are using Melody. Okay, if you can see, there were 4 types that were available with AudioCraft. AudioCraft is the library from which we have extracted this Melody pre-trained model. And Melody, we chose Melody because Melody was helping us with text to music, as well as we could use a text and melody as a combination. So it's the only model that can help us use both text as well as melody to generate music. That is what makes melody so interesting. And hence, all the other models, small, medium, and large, could be accordingly used depending on the resources consumption, which is one of the constraints regarding generating on your local system. So now we want to talk about the music gens architecture. Okay, we want to talk about the music gens architecture, and as we talk about its architecture, it's able to generate exceptional quality music. We said using a single language model architecture. The thing that makes it more and more powerful and interesting is that it is basically one of those models which is using the efficient token interleaving mechanism. So we'll tell you what this token interleaving in a couple of minutes. So it is conditioned both on text and melody, like humming or whistling, and is also built on the encodec architecture. So previously there was this encodec which was available, and the encodec. Let's discuss a bit on encodec as well. So this is the architecture primarily, where you would see that it is it has 3 parts, namely there's an encoder, there is a quantizer, and there is a decoder. So the encoder is fairly, it's a straightforward auto encoder module, and it has not been, nothing has been changed in the encoder part when we talk about the music gen, Meta's music gen. It is basically a standard convolutional architecture which churns out a vector representation for every frame in the input. So important part is that vector representation is being provided for every frame which we are giving as an input. So after that, the next step is after the encoder is your residual vector quantization, which is a special type of vector quantization. So the thing is, when we are talking about quantization and enablement of any such thing, very important to understand that any generic vector quantization was not possible. It had its own limitations, because when you use this music gen, you would see it as one of those models that wasn't able to actually, generate. Uh, I would say we were not able to use a standard method, standard vector quantization. So vector quantization is one of those techniques where I'm saying I am willing to do data compression and pattern recognition with what kind of data, with discrete data, or with continuous form of data into a mathematical form, into a finite set of representative vectors. So those representative forms or mathematical forms were known as codebook or centroids, and these centroids had to be laid down as and when we want to generate more music. So with the bit rate and frequency, it started becoming difficult, right? When we are talking about there is a set of frequency that you have to set and accordingly generate the right music. So if you see your MusicGen, it is trained over, it's an autoregressive transformer model, and it is trained over 32 kilohertz encodec tokenizer. So this basically, when we say 32 kilohertz of encodec, if we don't get into too much details, what exactly happens is, and I was talking about the centroids that are being created. So with normal vectorization technique, the possibility with per second generation of a particular bit rate was not possible. In short, if I would like to tell you that, but then we found this residual vectorization or vector quantization technique, where we imply a multi-stage quantization. We do it in multiple stages, and we have not a single code book, but we have some NQ code books where you could actually, specifically mention the number of quantizers, and accordingly we have number of code books. So for representation as of now, we've also showcased that there are 4 centroids or 4 code books that are being used for you know uh, that are being used for generation of music. So primarily, if you see, the number of centroids per code book is reduced here. So the centroids are again, the code books are what are the final outcome that we are requiring. uh, Code book basically map these centroids to a mathematical vector or the bit form per frame per second. So that again, the requirement was pretty high, with 2 to the power, let's say 80 is what were expected when we were trying to generate with 16,000 bits per second, 16,000 kilobits per second. So that became really difficult. So hence, we wanted to go for you know this residual vector quantization, which is a multi-stage process. Here we are able to have multiple code books, not just one, and then the number of centroids per code book also are reduced here. We generate 4 kinds of output per input frame with the help of this RVQ technique, and then further we put it through an interleaving process. So not to go too much into the technicalities of exactly how the mathematics behind this is working, but yes, a basic understanding that okay, we do a residual vector quantization. We have a 3-step process where we have an encoder, decoder, and a quantizer that help us in getting to the expected output, is what this model is all about. So how do you develop quickly? So we do understand that to be able to generate all this, we are using open source tools and libraries, and that's what we keep vouching for. You could use it, and you could, it's available to anyone and everyone. You are able to, get a decent amount of support from the world's developers all throughout the world, and it is highly qualitative. And you could also look for the right license. So even Meta mentions it under an MIT license, where it is restricting it from use, this particular model, for any any purpose, such as harming someone, by creating a music which is not, I would say, which is not very good, or something which is for harmful purposes, is only restriction that they have put along while you are using this model. The rest, you could use it for any purposes. So that is something that we always look when we are working with open source tools and libraries. So now let's get back onto our model and check out how is it working. So I will get back to, you just have to say yes, and this Jupyter notebook should open for you. Okay, yeah, you just have to say yes and your Jupyter notebook will open for you. Here, before I discuss the code, let us actually run one of the interesting, because this is again going to take a little bit longer to showcase the outcome. Reason being, this is going to take both the melody as well as Candy Kids. This is going to take melody as well as the text. So I would just go for one sample music file. It's a stock file that I have downloaded. Again, I'll have to share with sound here. Interesting part is, yeah, sharing with sound here. So I guess you maybe have heard the melody that I have just added here, and this is this kind of melody, and I would want to just change it into classical Indian soulful music. And for now, I'll set the duration as 5 itself, and then I'll wait for it to generate the required response. So what did I do? I just used the second tabbed interface on the Gradio here. We either have the text conditional, which I showcased you throughout the session, and this is another and the most interesting part, which melody is only capable of, this pre-trained model called melody, where I'm able to add a melody, and the duration for that should be maximum 30 seconds, and an input text as well to it. So let's say this was a music, very fast music, and a lively one as well. And to it, I have added this text that I would want it like a classical Indian soulful music. So I've submitted it. Let's wait for it to generate the music. In the meanwhile, we will discuss the code. I hope you guys have reached here. And this is particularly MusicGen is available in AudioCraft. And from there, we have imported MusicGen. You've also taken audio right so that you're able to write this audio. Torch audio also helps you capture the music, upload the music. Radio is again for the interface that we are using as of now. And we also have loaded our pre-trained model called Melody into this variable called model here, and then set the general model parameters. Okay, we've just set the general model parameters here. So we see that there is sampling. You could set it to true or false. There is a top K value that I was talking about. You could set it to 250. There is top P. They've set it to 0.0, but I guess we have set it to 250 here. So there are multiple such parameters that you can always look for the duration. Again, we see that I'm using it on the CPU. So I've kept it, we have reduced that, as just 5 seconds. And then there is flow, like CFG. There is one of those parameters called CFG. There is two-step CFG, extend stride. So you could go and actually look into details of each of these. Coefficient used for classifier, Fourier guidance, duration of generated waveform, soft mix temperature parameters. So that will help you and guide you in setting these model parameters and tinkering with these while you can submit a customization of this notebook that we have showcased you. Then coming to this part where we are talking about the portion of text being used to generate audio. So we just mentioned the description, whatever is the text and the duration here, and accordingly we are setting them based on the set generation parameters. You set the use sampling to true, the duration is being set as whatever is being provided by you, and then you can also do there is a possibility you could also set the stop K and duration from the radio, but then it will only complicate it. So we've kept it to the standard values, and then added that whatever mathematical vectorized form is there, added it to the audio values, and then we are returning the 32 kilohertz frequency with the audio values as a numpy mathematical array. Similarly, when we talk about melody conditioning, here we will add one more component, the extra music, right? This this extra that we have added. You see, it's still running, so it takes ample, good amount of time on your local system. And other applications are also running. A lot of CPU is getting, as well as RAM is getting consumed and occupied. So talking about the melody, so that melody gets loaded, the waveform is being captured here. Then that that waveform is then uh, mapped into a form of a mathematical forms. That same waveform is being mapped into a mathematical form or a vector form. Then with generate with chroma, this is where what is used, where the rate, the progress, etc. is being set, and your audio values are fetched. Just like above, the audio values are fetched. Then again, we've kept it to 32 kilohertz, getting the numpy array back as a return from this. And then this is Gradio, our actual interface. So this Gradio interface, this is for just to showcase, the activity, right? So here we have Gradio.text. So you could see this is here input text, all right. And then this is it's being mentioning the number minimum to maximum 10. Value is currently set to 5 seconds, okay, for duration. So to have a music generator one, a maximum to maximum is 10 seconds. And what kind of audio file you would have? You would have it in the form of numpy array, and the label for that will be the generated music here. Okay, we're still waiting. This, see, it has gone beyond 300 seconds for 5 minutes of duration. It could actually go up to 400 seconds. So that's what model is still running. So from here we will get one of the input interfaces for text, and then you will have the description as text conditional generation. Similarly, for melody conditional generation, we will have an option to upload the melody. We will that will be taken up as from a file path. We will have our melody uploaded, but our display text will showcase that the melody should have a maximum duration of 30 seconds, not more than that. And then again, you could add an input text, like I added that I want a classical Indian soulful music. Then again, the duration, we've set it minimum to 1 or maximum to 10 seconds. Currently, by default, you will see a value of 5 there. Okay. And then you have a tab for generated music. So then these two are tabbed into one single interface by using the gr.tabbed interface, putting them together as one under the same window. So that's here. And then, yeah, you will have it being launched in the browser directly. So we will have to just wait for a couple of minutes as well before this music actually gets generated here. So that's what this specifically does take some amount of time. In the meanwhile, we could actually take some questions from you guys. Oh, okay, actually we have our music being generated, so let me just play it and showcase. Could you just hear it? I believe this is my very, very interesting quality. And it is actually that classical Indian music. I'll replay this one which we used to generate it. And this one. Right? I would be happy to learn if you are able to check out this generated music which I just generated, and give your feedback as to how interesting this model could go, where you could generate anything, any melody of your own. So that's it from our session today, where we actually talked about how you could generate music through a single stage auto-regressive music gen transformer model, which is trained over some 32 kilohertz and uses your encodec tokenizer with 4 code books. And the sampling rate is at 50 hertz, 50 hertz, sorry. Unlike the existing models like MusicLM, this MusicGen does not require a self-supervised semantic representation, and it generates all the 4 code books in one pass. So by introducing a small delay between the code books, MusicGen is able to predict them in parallel, thus having only 50 autoregressive steps per second of audio. So I guess this is something that may sound a bit, unique, and that's how AI has progressed today. If you actually see, this is far more beyond what we were expecting in the year 2023 itself, where we saw, text being used to generate images, we saw text being used to generate video, and now today we are seeing text used to generate music as well. So you could actually increase and enhance it into your systems yourself. And before that, I would also like to answer two questions that we have from our viewers, our consistent viewers on the community platform. They have posted what is the maximum duration that can be generated. For now, we have set the model to a maximum of 10 seconds, but you will have to take it into consideration that you have a decent source or computation power onto your systems, the memory, the GPU, RAM. That will be something that you will have to take care of. And there's another question: why is it difficult to train a generative model for music? Okay. So first of all, working with sounds is not easy at all. It is basically modeling a long range sequences. Let's say people could say that it was easy to generate text to speech models, that because they were already existing. And when you're working with music, what you got to do is you have to go and satisfy a full frequency spectrum. This means working with heavy files, since music is sampled at 48 kilohertz. Also, musical melodies are composed of several instruments playing together. They have different sort of harmonies that are being generated, and it's a complete complex structure. And in fact, as humans, we are sensitive to disharmonies and easily notice melodic errors. However, paradoxically, we notice very few errors in generated images. So that's why it is easy to generate images, etc. However, using a textual prompt to generate melody is something that needs to be still worked upon. So I guess this is it from our session today. I would look forward to any more interesting questions that you may have. You could post those on your on the community platform, and I hope you were able to experiment with this kit well. Thank you.
Thank you, Pooja, for that lovely session. For all our viewers and bootcamp participants, we hope you enjoyed the session and found the use case that was presented valuable. Please note that all of you who participated will be eligible to receive certificates for this bootcamp. In order to receive your certificate, please complete the assessment by answering two very simple questions. You can do that by scrolling down from on the same page where you're viewing the bootcamp today. You will find a Take Assessment button. Click that button and complete the assessment. You should then receive your certificates in less than a week from today. We will be conducting such bootcamps frequently and regularly. So if you'd like to stay updated with our program calendar, do join our community on community.openweaver.com. This community is where we will connect with you. It helps us receive feedback from you. It helps us understand topics for future bootcamps. But also you can use this community space to collaborate with each other, to ask us any questions and receive clarification if you'd like. Or just share your projects and anything else that you would like to in the world of open source. So do join our community and also follow us on our social media channels to stay updated on information and trends in the world of open source. With that, I would like to thank you all for your participation today, and I look forward to seeing you in yet another bootcamp very soon. Thank you and good evening.